Welcome aboard, everyone. Ready for another deep dive.
Always.
Today, we're going to tackle visual flight rules, VFR. You know how pilots navigate using charts and, well, their wits when they're not relying on fancy instruments.
It's a fascinating topic, really. It blends geography, physics, and careful planning all into one.
Right. We'll be covering everything from aeronautical charts, those roadmaps for the sky, to understanding how wind can drift a plane like a sailboat. Our source for this deep dive, an excerpt from a pilot training manual. So buckle up, get ready for some pilot lingo, and let's get started.
I'm ready when you are.
Okay, first things first, those aeronautical charts. Just like a road trip, pilots need maps, and they have a few types.
Think of it like zooming in and out on your phone. You have the big picture, then you can zoom in for details as you get closer. For pilots, sectional charts are the wide-angle lens. They cover large areas but still show airports, navigation aids, even terrain.
So sectional charts are the wide view. What about those close-ups?
For those, you'd use a VFR terminal area chart, essential when flying near busy airports, especially those with Class B airspace, like navigating a city center.
You need the detailed map to avoid wrong turns.
Exactly.
Makes sense. But what about those long hauls? Across continents, even the world?
That's where the World Aeronautical Chart comes in. Imagine a map covering the entire globe. Obviously less detailed than a sectional chart, but crucial for long distances.
Wow, I can't even imagine trying to fold that back up.
Right, a real challenge.
Okay, so we have our maps. But before plotting a course, we need to understand Earth's grid system. Latitude and longitude, those old friends from geography class.
Right, latitude tells you how far north or south you are from the equator. Think of those lines circling Earth like belts. Longitude tells you how far east or west you are from the prime meridian.
Okay, I remember that much. But honestly, I never understood why it was so important for pilots. Isn't it all about landmarks and visual cues?
Landmarks are important, sure, but Earth's grid system is what allows pilots to pinpoint their exact location on a chart. Plus, there's another interesting bit. Longitude links to time zones.
Ah, time zones. That's why long flights can be so disorienting. You're traveling through time.
Exactly. Every 15 degrees of longitude is a 1-hour time difference, like a giant orange with 24 slices, each slice a different time zone. Pilots fly across those slices, they have to adjust their clocks and their bodies.
So are they constantly doing time zone math?
Well, not exactly. To avoid confusion, aviation uses Coordinated Universal Time, or UTC. It's like a pilot's time zone, keeps everyone on the same page no matter where they are.
Makes sense, like a metric system for time. Speaking of keeping things straight, the manual mentions true course. What exactly is that?
True course is the straight line you draw on a chart from point A to point B.
Sounds simple enough.
But, and here's the interesting part, a compass doesn't always point true north.
Wait, what? I thought that was the whole point of a compass.
Well, there's true north, the geographic North Pole, and then there's magnetic north, where your compasses points the difference. That's variation, and it can be significant depending where you are.
So how do pilots account for this? Just guess.
Not quite. They use isogonic lines on their charts. They look like those squiggly magenta lines, each representing a specific variation.
And so they're compensating for Earth's magnetic field to make sure they're flying the right way.
Precisely. Crucial for accurate navigation, especially over long distances.
Okay, so true course, adjust for variation, we're good.
Not so fast. There's another factor. Deviation.
Deviation, what now?
Even the plane itself can affect the compass. Metal, electrical equipment, it creates its own magnetic field interfering with the compass.
So like using a compass in a giant metal box.
Exactly. Pilots have a deviation card for their aircraft. It tells them how much to adjust the compass based on the plane's heading.
Wow, so much to consider just to know where to point the plane. I'm starting to see why pilots need to be so detail-oriented.
Detail is key, absolutely. And it gets even more challenging with wind, that one element that can make or break a flight.
Wind. We all know it can push a plane off course,
Yes.
but the manual really highlights how significant its impact is.
What's fascinating is that wind doesn't actually change the plane's airspeed. That stays the same. What changes the plane speed relative to the ground, or ground speed.
Okay, I think I'm following. So tailwind, like a free boost, get to your destination faster. But a headwind, that's like swimming upstream.
Perfect analogy. And wind from the side, you got to think like a sailboat captain, constantly adjusting your course.
Which brings us to drift angle.
Right. Drift angle is the difference between where the plane's pointing, its heading, and the actual path it flies over the ground, its track. Pilots constantly adjust for drift, especially with strong crosswinds.
So it's not just point and go, it's this dance between heading, wind, and the actual path you're flying.
Exactly. A dynamic process requires constant awareness.
I feel like I need a degree in aeronautics just to keep up. So how do pilots actually calculate all these factors, especially midair? Superhuman mental math.
They have a tool, the wind triangle.
Wind triangle. Sounds ominous.
Actually, it's pretty simple. Imagine a triangle, each side a force. Airspeed, wind, and ground speed. Knowing two, pilots use the triangle to figure out the third.
So they know their airspeed and the wind. They use the wind triangle to calculate ground speed and what heading they need to stay on course.
Precisely. Crucial for figuring out flight time and, more importantly, fuel.
Ah, fuel, the lifeblood of any flight. Speaking of, I think we should refuel ourselves with a quick break. Be right back. We're back and ready to tackle fuel planning. As they say, fuel is a pilot's best friend.
Absolutely, running out mid-flight, not a good time.
Right, it's more than just topping off the tank and hoping for the best. You have to consider the distance, the ground speed, and fuel consumption rate.
And you always have to factor in reserve fuel, basically an emergency stash in case of delays or detours.
A backup plan, but for fuel. Safety first, always. But are we talking hours of complex math here?
Well, it can be complex, but pilots have tools to help. Remember those flight computers?
Ah, yes, the E6B, a true pilot, essentially.
Exactly. They're like specialized calculators for those tricky flight planning problems. Figuring out fuel needs, time, conversions.
Like a pilot's Swiss Army knife for numbers?
You could say that. And then there are plotters. They're like fancy protractors to measure distances on charts and determine true courses.
So many specialized tools. It really shows how precise aviation is.
It's all about minimizing risks, maximizing safety.
Speaking of safety, the manual also mentions flight plans. Now, I know they aren't always required for VFR, but seems like a good idea, just in case.
Absolutely. Think of it like a breadcrumb trail. For search and rescue, if something happens, it gives them an idea of where to look, if a plane goes off course or has an emergency.
A high-tech breadcrumb trail. So you file your plan, detailing the route, estimated time, fuel on board, all those vital details. But what about navigating once you're up in the air, especially with few landmarks?
That's where radio navigation comes in. The manual talks about three main ones: VOR, ADF, and of course, GPS.
Okay, I know GPS, that's how I find the grocery store, but VOR and ADF, those are new.
Think of VOR, VHF omnidirectional range, as a network of radio beacons spread across the country. Each station sends signals in all directions.
Like spokes on a wheel.
Exactly. Pilots use these signals to figure out their position relative to the station.
So they have an instrument that tells them which spoke they're on, and whether they're going towards or away from the hub.
It's a good way to put it. An ADF, automatic direction finder, it works similarly, but it uses ground-based radio beacons called NDBs.
So both use radio waves to help pilots navigate. Yeah. But what are the pros and cons of each?
Well, VOR signals are VHF, so they're line of sight, like beams from a lighthouse, if you're too far, or something's blocking the beam, like a mountain, you won't see it. Same for VOR. Too low, too far, you lose the signal.
All right, so what about ADF then?
ADF signals can travel further and aren't as affected by obstacles, but they're more prone to interference, like from thunderstorms.
Okay, so different tools for different situations. Can't always rely on just one system.
Right. Pilots often use multiple systems to cross-check their position. Redundancy is key in aviation.
Backup plans and being prepared. Speaking of backups, the manual mentions VFR waypoints. What are those exactly?
Think of them as virtual landmarks in the sky, predefined points for extra navigation support, especially when flying in areas with few visual landmarks.
Or like extra checkpoints along your route to make sure you're on track.
Exactly. Helpful when navigating around busy airspace or tricky terrain.
So we've talked about all these tools for navigating, but what if, things go wrong? Pilot gets lost, unexpected situation.
Yeah. Right. Well, the manual outlines some strategies for those moments. First rule, climb.
Climb? Why climb?
It improves radio reception, gives you a better view, like a bird's eye perspective to reorient yourself.
Okay, that makes sense. What else?
Try to communicate with nearby facilities like air traffic control or flight service stations. They might be able to help, give you directions, or even a radar guidance.
So even when lost, there's help available.
Exactly. Systems are in place. The manual also talks about being prepared for flight diversions.
Flight diversions? What are those?
Basically an unplanned detour. When a pilot changes their destination mid-flight, bad weather, mechanical issues, low fuel, things like that.
Like taking an unexpected exit on a road trip.
Exactly. The key is quick thinking and good planning.
So have backup options in mind, alternate airports, and be ready to recalculate your course, fuel, estimated arrival time, all on the fly.
That's right. Stay calm, assess the situation, and make the best decisions for safety.
This is a lot to process. Makes you appreciate the complexity of navigating a plane.
It really is a testament to the skill of pilots.
Okay, so we've covered charts, compasses, radio navigation, emergency procedures. But one more system we can't ignore, GPS. That's where our final segment will take us. Exploring the tech that revolutionized navigation, not just for pilots, but everyone. All right, we're back and ready for GPS, the Global Positioning System. It's become so common, we forget how revolutionary it is.
It really is. I remember the days before GPS. Paper maps, compasses, lots of guesswork. GPS changed everything for everyone, not just pilots.
Can't imagine finding my way around without it. But for pilots, it's more than convenience. It's about safety and precision.
Absolutely. Unlike VOR and ADF, which rely on ground stations, GPS uses satellites orbiting Earth. So no line of sight problems, no interference from mountains or storms.
So clear view of the sky, you get a position fix anywhere.
Pretty much. It's a global system, much more accurate and reliable.
Incredible.
Yeah.
But I've always wondered how GPS works. How can satellites tell you where you are on the ground?
It's all about triangulation. Each satellite sends a signal with its position and the exact time it was sent.
And your GPS receiver picks up these signals from multiple satellites.
Right, and by comparing the arrival times, it calculates the distance to each one.
Okay, so let's say you're getting signals from 3 satellites. You know how far you are from each.
Exactly. Then the receiver uses some math to figure out your location, like drawing circles around each satellite with your distance as the radius. Where they intersect, that's you.
Wow, complex, but simple when you break it down. The manual mentions RAIM. What's that?
RAIM, Receiver Autonomous Integrity Monitoring. It's a safety feature, double-checks the satellite data.
Quality control for your GPS signals.
Exactly. It can tell if a satellite's info is wrong, alerts the pilot. An extra layer of protection for the GNSS data.
Sounds reassuring. So GPS seems like the perfect solution. Accurate, reliable, global. Any downsides? Limitations pilots need to know.
A few things to consider. One is database currency. GPS receivers use databases for info on airports, waypoints, airspace. If those aren't up to date, the info could be wrong.
So a pilot might think they're clear of restricted airspace, but they're not.
Right, keeping databases current is crucial. Another issue is antenna placement, especially for VFR. IFR flights have antennas positioned for optimal signal. But VFR pilots, especially with handhelds, might not be as careful.
Signal blocked by the plane or the antenna held the wrong way.
Exactly. And without RAIM, the pilot might not even know the position is off. So it's important to understand GPS's limitations. Use it as a tool, along with other techniques, especially for visual flights.
Technology is great, but not perfect. Pilots still need to think critically, double-check, use good judgment.
Absolutely, tech helps, but it shouldn't replace skill and judgment.
Well, I think we've successfully navigated this deep dive into VFR navigation. We've covered charts, compasses, radio systems, GPS, everything. It's amazing what it takes to get a plane from A to B, especially when relying on visual cues.
It really shows the skill of these pilots.
After learning all this, I have a new appreciation for what they do. Not as simple as it seems from the ground.
Not at all. Knowledge, skill, situational awareness, it all matters.
So for all of you listening, explore aviation further. Try a flight simulator, experience the challenge of flying. Or, be adventurous, take a discovery flight with an instructor. Maybe you'll find a passion for flying too.
And if you're ever in the cockpit, remember what we've learned. Stay aware, think ahead, and never underestimate a good map and a clear head. Safe travels, everyone.